Hi everyone, and welcome to Activity 27, Part 2. Today we are going to talk about our hyperbolas. Now, a hyperbola is basically a mirror image of one another. So what we're going to kind of see is basically two pieces opening away from one another. So how this is going to look is if this is a horizontal transverse axis, we see that they will open to the right and left and also like back to back. Horizontal parabolas, vertical is going to open up and down of one another. Now notice some things with the equations is they're similar to an ellipse. However, your a squared value this time now is going to always be first. So you're going to notice in here a squared is always first. What's going to dictate if it is horizontal or vertical is what comes first, either the x squared if it's horizontal or the y squared if it's vertical. And some of the things that we see with the equation of hyperbola are similar to that of an ellipse. However, A is no longer the biggest parameter. C is going to be our biggest parameter. So C squared is the biggest, where in an ellipse, A was always the biggest. So we have to be careful on that. We also are now no longer, since A is no longer the biggest, we don't call it the major axis anymore. We call it the transverse axis. 2B then is the conjugate axis. And again, A might be the smallest this time. The biggest thing, though, is that C is the biggest. We also have these equations of our asymptote lines that they are following along being given. The biggest thing is that the slope for horizontal is B over A, slope for vertical is A over B. Okay, so we have some pieces we can start out with on this first example. Notice that this time we have an H value and a K value. Our H value this time is with the X, so that's going to be 3. K value is with the Y, that is at -1. So again, we want to always be careful which is coming first. In this case, since our Y value is coming first, we know that this should have a vertical shape to it when we go to graph. Now this time A squared is 16, so our A value is just 4. So 2 times A then is going to just be 8. Conjugate axis, B squared is 4, so B is the square root of that, which is 2. 2 times that value would be 4. Our vertices then, since A is with the Y values, are going to come A units up, so 1, 2, 3, 4 units up, and 1, 2, 3, 4 units down. So these vertices are going to be at 3, 3, and 3, -5. Co-vertices then are coming to the right and left, 2 units. So 2 units to the left and 2 units to the right, put us at 1, -1, and 5, -1. Now what's going to happen is, in order to actually graph this, what we're going to do is we're going to kind of connect these dots to make a box, but we're only going to kind of dash that because what's going to happen is through the center and then basically the kind of diagonals here in this box. These are what we call the asymptotes of our hyperbola. And what's going to happen is then at the vertices, again, this is opening up and down, we are going to just follow along. So you can kind of see how wide or narrow these are based on that. And the slope of those asymptotes that it's following along, okay, again, we always plug in y minus k, so +1. And then since this is a vertical, it's going to be our B value over our A value reduced, our A value over our B value, because in this case, notice we rose 4, ran 2. 4 over 2 would be rising 2, running 1 each time. And then x minus 3. Last but not least, our foci. Okay, similar to an ellipse will be on that axis with parameter A, aka the transverse axis this time. We know C squared is A squared plus B squared. So the square root of 20, which is going to be about 4.5-ish, is going to end up being our C value. So we're going to go up from our center 1, 2, 3, 4.5-ish, down 4.5-ish. So again, you could represent that a couple different ways. Exact value-wise, we would say 3 comma -1 plus or minus square root of 20, or you could use the decimal approximations as well. All right, next example then is asking us to, again, find the different pieces. This time we're going to end up with a horizontal whose center is, again, at 3, -1. So it's going to be opening horizontally because the x's are there. Our a value, is going to be, again, underneath the beginning term this time. So this time our a value, if a squared is 4, a is going to be 2. So our transverse axis length would be 2 times that, so 4. B squared then is 9, so square root of that is 3. 2 times that is going to be the length of that conjugate axis, so 6. So parameter A, again, is underneath the x's, so we're going to the right 2 and to the left 2, so that we are at 1, -1, and 5, -1. And then the co-vertices are going up and down, in this case, 1, 2, 3, 1, 2, 3. And again, to actually graph this, then we're going to connect the dots of the box. Asymptotes go through the diagonals, and then we start at each of those 2 vertices and go along those asymptotes so we can see exactly how wide it is opening. So in this case, those co-vertices, again, were up and down. They were at 3, 2 and 3, -4. And then the slopes of those asymptotes, y minus our k value, plus or minus b over a this time. So 3 over 2, x minus h. Now the foci this time, right, our c squared value is going to come from taking a plus b, so in this case square root of 13, which is about 3.6. So we'll go to the right 1, 2, 3.6, go to the left 1, 2, 3.6, so that again you could write it as 3 plus or minus square root of 13. You could have written it with the decimal approximations as well. For each of those 2 points, you could do 3 plus the square root of 13. So you would be at about 6.6 comma -1, or 3 minus square root of 13. We'd be at -0.6 comma -1. All right, our last part is going to be talking about writing our equation in our standard form. So very similar to our ellipses, we want to start by grouping. Now in this case, I tend to like to group whatever my positive variable is first, and then I'm usually going to have, when it's a hyperbola, you're going to have one that is negative. I'm going to group that second, and then add over that 1 to the other side as well. And again, like our ellipses, we have to start by taking out any GCF so that we are actually able to complete the square. Now be careful on the second one, there is officially a -1 that we are going to take out, so this actually becomes x squared plus 2x for our x values. So on this side, divide by 2 and square, we end up with 1. And then don't forget to multiply by the 16 to add over. Divide by 2 and square, we have 1 again. Remember, you are multiplying, though, by that GCF, this time -1, and adding that over. So when we start factoring, we end up with 16 times y plus 1 quantity squared. And then minus 1 times x plus 1 quantity squared, and that's going to equal 16. And then we can divide over as well. So our final answer after we reduce, we end up with y plus 1 quantity squared. The 16s kind of cancel. You could either just leave it like that or put the 1 in the denominator. And then x plus 1 quantity squared over 16 equals 1. Okay, last one then will be for you to try. Okay, don't forget you end up wanting to group these to start and look for any GCFs as necessary. Now the nice thing for this first one is with the y's, or the x's, excuse me, you are not going to have to worry, but oops, it is minus 9y squared plus 18y, and then we can move that 14 over to the right-hand side. Just remember to kick this off when you start, before you can complete the square, you are going to want to look at that GCF to factor out. Thanks everyone for watching. We'll work more with these in class.